All right, let's get into chapter 9. Basically, we're going to cover 4 things. Here, creating ceilings, creating ceiling openings and soffits. Should be very, very simple. You guys will really like the automatic ceiling tool. Adding interior design, that's things like casework and toilets and partitions, and really adds a lot of information to your model. And adding alternate floor materials. So we'll get right into creating ceilings. Item 1, go to level 1 ceiling plan as shown in figure 9.1. Alright, so here in the project browser it has floor plans and it has ceiling plans. And really up to this point most of the work we've done in floor plans. So just collapse that and open up your ceiling plans and make sure you're in level 1. And you'll know you're in a ceiling plan because you shouldn't see doors. So just to give you a contrast, if I go to the level 1 floor plan, I have all these doors. If I go to the level 1 ceiling plan, no doors. It's a good quick way to make sure you're in the right place. On the architecture tab, click the ceiling button. So if we go up here, ceiling. With the ceiling command active, choose 2x4 ACT system. That's going to be here in your properties. And by default, it already has a 2x4 ACT system, but in this type selector you could choose a 2x2, gypsum board, or metal stud, or like a slab or a wall assembly, you can create your ceilings assembly. So we're going to stick with the generic 2x4 system here. Item 4. Hover your mouse over the room shown in figure 9.3. Notice that the perimeter is outlined in red. This indicates that the ceiling has found at least 4 walls it can use as a layout. So if we come over here to this wall, you see that it creates this red highlight. Revit is smart enough to know that ceilings are typically bound by walls. Just like if you look in this room above your head, this ceiling extends to the 4 walls. Only in very special cases will it not extend to the 4 walls. If we click here, there's our ceiling. Pretty simple, right? Okay, now item 6 asks us, add a ceiling to every room in the wing except the bathrooms. So literally, this is going to be as simple as clicking to add these ceilings. Has anybody ever done a reflected ceiling plan in AutoCAD? Well, you would typically come in and you draw all these lines. And it really it wasn't time consuming, but it could be very irritating to have to go in and draw all of that. It certainly took more time than what we just did here. And the nice thing about this as opposed to AutoCAD, where literally was just a series of lines, is this is an active ceiling. It understands that the module is 2 foot by 4 foot. And it automatically centers it on the room. Now, it may not center it exactly the way you want it centered, and we're going to show you here in a minute how to change the orientation and adjust those things. Not very difficult at all, but it always understands it's a 2x4, so you don't end up with some weird module like 2 foot by 3 foot. I've seen that happen on drawings before where somebody has offset something and not realized it, and they end up with a 3 foot piece of tile in the middle of the floor of the room. Hopefully that gets caught during construction and you make the necessary adjustments, but it's very difficult to make that mistake here. Alright. Item 7, with the ceiling command still running, select the compound gypsum wall board on metal stud. Okay, and for we're going to pick the bathrooms and put that in there, and you know it's changed because you see the pattern change there. So right now what we have is typical acoustical ceiling tile ceilings in all the rooms except the bathrooms, where we have gypsum wallboard, which is also referred to as hard lid. And if you walk through this building that you're in, that's pretty much the type of ceilings that you're going to see. Classrooms, we have ACT ceilings. These happen to be 2x2 grids as opposed to 2x4 grids. But if you go in the bathroom, you have a hard ceiling. Why do you think that is? In case it floods? No, hopefully the room doesn't flood all the way to the ceiling. But you're headed down the right track there. Moisture, right? So if you look at these ceilings, they're very porous. They're porous because they act to attenuate the acoustic noise. Even if you walk into a, say, a kitchen area, you'll notice that the ceiling tiles above the food preparation area don't look the same as the ceiling tiles out in the main. Look at the next time you go to a quick service restaurant, fast food restaurant. You'll notice that the ACT ceiling in the dining room is different than the ACT ceiling above the kitchen. And that's because they make them put vinyl coated or non-absorbent ceiling tiles above the kitchen because they don't want the moisture and the grease absorbing into the tile. So if you were designing a building, say a school like what we're in, it would be common to see a hard lid in the bathroom areas for moisture reasons. Alright, item 9, press escape to get out of that command. And then we'll move on to item 10. Modifying ceiling grids. To be honest, a ceiling consists of nothing more than a basic hatch pattern applied to a material. Actually, everything in Revit is a basic hatch pattern applied to material. The one unique thing about hatch patterns is Revit that you can modify them on screen. That means you can move and rotate a hatch pattern. It also means you can move and rotate a grid pattern. Item 1, press escape or modify to cancel the command you're in. We've already done that. Item 2, pick a ceiling grid line as shown in figure 9.6. Alright, so we're going to pick this grid line. And really, what I'm going to tell you is you only really want to move this grid line in 24-inch increments. So when you pick it, and you click, and you drag, you want to make sure you're doing that in 24-inch increments, and where you don't end up, let's see if I can do it without doing it in 24-inch increments. See here we have, it's not centered any longer. These tiles on this side are much larger than these tiles on this side. You don't typically want to do that. You want to center it where these are the way that you want them to be. And a lot of times what you can do to make sure you're doing that, like now I've totally screwed this one up, right? To show you not to do that. I can type DL for a detail line. And I can draw an X across that room. And what that does is it shows me the exact center of the room. Right? So I'm going to draw another detail line there. And I'm going to take and I'm going to offset that detail line 24 inches. No, not 24 feet, 24 inches. Alright, so I know that my grid really needs to line right there for it to be centered. Does that make sense? So now I can drag this with some precision. And again, we want to be as precise as possible when we're laying out ceiling grids. Now, how do you lay out a ceiling grid? What drives the layout of ceiling grid? No. Any guesses? How would you determine where, if your ceiling grid should be this way or move 24 inches? Should this ceiling grid in this room be like this? Or should it be like this?
Like that.
Why?
Because it's like the perfect amount of tiles for the room, right?
Nope. This is not the way you want this grid. If you had to put lights in here, how would you put lights in here? That's not a full tile. So you could only put a light there, a light there. And you want your lights evenly spaced. So if we undo that, now I can put a light here, I can put a light here, which is 4 foot apart, right? And I can go 4 foot here and put a light here. And I can put a light here. I can put 4 lights in this room and get a very even spread of light across them. So when you're thinking about a ceiling, how to lay out a ceiling grid, especially 2x4, 2x2 is a little bit easier. It's all square. Or in like a room like this where we have pendant light fixtures, not as important. But when you're doing typical lay-in fixtures, which is what most rooms have in them, you need to think about the lighting layout. So this is a conversation that you would have not only internally with your peers in the architecture field, but you would involve your electrical engineer and say, hey, how do we intend to light this room? This direction, it looks pretty good. We could do the same thing here and shift this over 12 inches. I don't think we're going to gain anything by doing that. We would just end up with small tiles on either side. So this, for me, is the correct layout for this room. So everybody understand how to adjust this grid.
Okay.
Yeah.
You offset 24 inches. Is that where you went?
I offset this detail line 24 inches.
Okay.
Yeah. So, and what you're going to want to make sure is when you're done with these detail lines, delete them because they will show up. Get rid of them. They were really just there as a drawing tool for you. Alright, now if you wanted to do something weird, you could rotate this line. And it would rotate the entire grid. Why you would ever do this in this particular room is beyond me. But it does allow you to rotate the grid if you had to for some reason, if it wasn't in the right orientation. For example, if you wanted the grid to line up with this wall for some reason, you could rotate this entire grid. But you end up with really weird cuts all the way around, and that's one of those things, just because you can do it, use it sparingly. It doesn't mean you have to do it. Well, the book says it wants it because it's showing you that it can be done. Doesn't mean it's necessarily a proper thing to do. Remember when we said earlier in the semester that this building is not like a really well-designed building? It's a building designed to show you all the different things that Revit could possibly do. So yes, you could rotate that just like the book shows. But I can't see a good reason for doing it in the real world. So I'm telling you, just because you can do it, and Revit has the ability to do it, doesn't mean that you don't still have to think about the real world constraints when you're laying out your ceiling.
So, Jeff, you did the offset, and then what did you do with the grid?
I just grabbed one of the lines and I moved the line. Okay, so that takes us through kind of how to manipulate a grid, moving the lines back and forth, rotating it. Very simple. On to the next task here in the Chapter 9. Setting ceiling element properties. As I mentioned earlier, ceilings are set up in a fashion similar to floors. So it stands to reason that you'll see many similar properties. Before you get started, let's make some modifications to the west wing. The object of this procedure is to add a hard ceiling with metal framing, gypsum, and a 3/4 inch cherry finish. To do so, however, you need to modify some of the walls. Item 1, go to a 3D view of the model. So I'm just going to click default 3D view here on the quick access toolbar. Select the roof and right click. We're going to right click. And we're going to go to override graphics and view by elements. Okay. In the View Specific Elements Graphics dialog box, select the small downward pointing arrow in the Surface Transparency row and slide the transparency to 50%. Or you could just simply type 50% in there. What that's done is it's literally just made it transparent so we can see through, so we can work. And really, we're going to be working on these walls here. You made the roof transparent because some of the walls have to be attached to the roof. It's much easier to attach the walls in a 3D view, but to do so, you need to see the walls to which you'll be working. Item 1, select the wall shown in figure 9.11. We got that. Item 2, on the Modify Walls tab, click the Attach Top Base button. We'll do that. We'll select this wall. And just like we did with the exterior walls, it takes the interior wall up to the element. Now, if I move this roof for whatever reason, what would happen to the wall? It would follow it, right? It would continue to be attached and be able to be modified by it. Okay. The next step is to constrain the partition walls in this area to level 3. The ceilings you'll add to these rooms will be much higher than those in the rest of the building. Follow these steps. While still in the 3D, select the partitions shown in figure 9.12. That's these partitions back here. So I'm going to hit the control button. And I'm going to rotate around, make sure I got all of them. And it appears I did not, so I'll select that. It looks like I should have 5 walls. In the properties dialog box, set the top constraint up to level 3. So we have our base constraint at level 1. We have our top constraint up to level corridor. We want to take that up to level 3. We'll hit apply, and you'll notice that all those walls shifted down just a little bit. Select the roof that is transparent, right click, go into the override graphics and view by element, and reset. Click the reset button and then click OK. Okay, so now that we're done with this, override graphics by element. We just want to hit reset, and that will take all this to the default. Hit apply, hit OK, and now our roof is no longer transparent. So basically, what Revit, or what the book was showing you there, is it's easy to turn the transparency of things to a point where you can see through them to continue working on your model. The beauty of this thing being in 3D is, if it doesn't make sense in 2D, you can open up the 3D view and start to dissect what you're trying to do. Alright. Item 4. Go to level 1 under ceiling plans. Alright, so we'll go back to the project browser. Not the floor plans, I'm going to collapse that, but level 1 on the ceiling plan. And we're back. So we're going to be working over here now, obviously. The next procedure is a tad off the beaten path, but it fits squarely within the process. Because you've specified the walls in this area to be of a greater height than the rest of the walls in the model, you're obviously adding ceilings higher than 8 foot. This poses a problem in terms of the level 1 ceiling plan view range. Creating a plan region. We've done this before, so this should be a review. Sometimes you'll need to set your view range in a specific area that differs from the view range in the plan as a whole. In this example, you'll add ceilings at 14 foot 6 above the finished floor. If you do this with the current view range settings, Revit won't display the ceilings. If you modify the view range for the entire view, you'll see the 14 foot 6 ceilings, but you won't see the 8 foot ceilings in the rest of the building in that view. In the following procedure, you'll create a region that has a different view range as compared to the view range in the level 1 ceiling plan. Item 1 in the project browser, make sure you're in level 1 ceiling plan. We are. Item 2, zoom in the west wing. We have. On the View tab, select Plan Views, Plan Region. So we'll go View tab, Plan Views, Plan Region, which takes us into what? Sketch mode, right? So typically in sketch mode, what are we doing? We're drawing a boundary, right? Closed boundary is what we need to be focused on here. Pick the inside finished face of the exterior walls around the north portion of the west wing. See figure 9.13. So you can do this by picking a line. And I'm going to pick that line, and this line, and that line, that line. It doesn't want to let me pick that line. What am I going to do?
Draw.
Yeah, I could draw it. But I don't have an arch tool. What do I do? You're going to take this and you're just going to draw a couple straight lines. Oh, make sure your chain is selected. And you don't have to be super precise about this, but the more lines you draw, the more precise you'll be. And you can see if I zoom in real close, there's a little discrepancy there, but who's ever going to see that? Nobody really. It's one of those things where you have to judge. How much time do I want to spend drawing that arc? Because I don't have a tool to draw it with. Alright. Now we're going to before we finish this, we're going to come in and edit the view range. We're going to set the top level to level 3. We're going to set the cut plane offset to 14 foot 6 inches. We're going to set the bottom offset to 7 foot 6 inches. And we're going to set our view depth to level 2 with an offset of 16 feet. And we're going to hit apply. On the mode panel, click the Finish Edit mode. Lines cannot intersect each other. Highlighted lines currently intersect. What do I have here? I don't have a complete boundary, right? So what should I do? Yeah, well, don't hit quit sketching. Hit continue. Trim to corner. Fix that. And now finish the mode. And there we go. So has anything really changed? Do you see anything different? Not yet, but when we start to draw these ceilings in, you'll be able to actually see them because we took the time to modify the view range. Now, could we have drawn the ceilings and then modified the view range later? Absolutely. So if you draw something and it doesn't show up, what should your first instinct be? Check the view range. Check the view range. Alright, the next item, creating a custom ceiling. So what do you do if your ceiling isn't actually a tile ceiling or gypsum board system? You make a new one. As mentioned earlier, creating a ceiling is similar to creating a floor or roof. The properties dialog boxes are exactly the same. Procedure guiding you through the process of creating a custom ceiling. Be sure you're in the level 1 ceiling plan. Zoom into the northwest room. On the Architecture tab, click the Ceiling button. Alright. In the Type selector, select Gypsum Wallboard on metal stud. To the right and below the picture is the Edit Type button. So what's the first thing we do when we edit a type? Duplicate it. Absolutely. And it's going to let us rename it. And we want to rename it Wood Veneer on Metal Framing. And what have we said about how we name things? Yeah, well, all caps, yeah, that's kind of secondary to name them something that makes sense. Don't name this ceiling number 2. Name it something that if somebody who was working on the project that wasn't familiar with the project could go, oh, okay, I see that that's the ceiling that we're using. In the Structures row, click the Edit button. In the Layers field, as shown in Figure 9.16, click Row 4. This is the Finish 2.5 gypsum wallboard, okay? The entire row should be highlighted in black when you have it selected properly. Item 8, just below the Layers field is the Insert button. Click it. Change the function from Structure to Finish to parentheses 5 or brackets 5 and move that down so it's below the gypsum wallboard. We're adding another finished material below the gypsum board, which will be the wood veneer. Click in the material cell and click the ... button. Which opens up the material browser. In the top of the material browser dialog, type cherry. Okay. In the material editor dialog box to the right, click the field next to pattern. All right, so right now we don't have a surface pattern, but we're going to get a surface pattern. go to wood pattern 1. Okay. Click OK. Below the surface pattern category, expand the cut pattern category and change the pattern field to plywood. So these are the patterns that are going to show up on the surface and when we cut that material in like a section or a detail. So we don't have to draw this stuff in after the fact, right? It's part of the properties of the material. Everybody with me still? In the shading category, click under the render appearance. Okay, use render appearance. So when we go to a shaded view, it will try to make it look like the rendering. In the material browser, click OK. Change the thickness to 3/4 of an inch. Click OK twice. So now we've created a new ceiling, right? And we've created a new ceiling based on a ceiling we already had. So we already had gypsum wall board in place. We already had metal framing in place. We made another ceiling. And you don't have to. I think that's an important thing about Revit in general. You don't have to recreate everything from scratch. Take something that's already basically what you want and modify it as necessary for your particular application, if it's appropriate. If it's not appropriate, then you can create it entirely from scratch. In the Properties dialog box, change the height offset from level to 14 foot 6 inches. Alright, so it's at 8 foot right now. We don't want it at 8 foot. We want it at 14 foot 6 inches. Right. And then we're going to put a ceiling in that room. And we know that ceiling's there. Why? Yeah, because we can see the pattern that we just selected. So we're going to put that in all these rooms. These are going to be like high-end meeting rooms, evidently, or offices, something nice. Okay, so this takes us really through figure 19.9, or 9.19 rather. My apologies. All right. So the next thing we're going to do is we're going to create some openings in these ceilings and put some soffits in them. We're going to create holes. Holes are easy to create, right? Creating ceiling openings and soffits. Unless you're in a residential dwelling, a prison, or a subway, you can look up and notice that ceiling is merely serving as a host for electrical, mechanical, and architectural components. Seldom will you find a ceiling that doesn't require modification in some capacity. This section of the chapter deals with this issue, starting with creating a ceiling opening. The objective of the next procedure is to cut an opening into a ceiling, into which you'll drop a soffit later. Creating a ceiling opening. Open the level 1 ceiling plan. Zoom into the wood ceiling in the west wing as shown in figure 9.20, which is this one we just put in. Select the ceiling in the northwest corner of the building and click the Edit Boundary button. Oh, what happened? What did I just do? I didn't escape out of it, so I put another ceiling in the same place. So I want to hit Control Z. Oh, I did it again. Hit Control Z, then hit Escape. What I want to do here is go into my filter and see how many ceilings I have. I only have one. Good. Okay. So now I want to select this ceiling. And it's going to be kind of difficult. Why would it be difficult? Because if I click in the middle of this ceiling, what happens? Nothing. You really want to select your ceilings by the edge. If you have to turn off a wall temporarily to do that, then do that. But you'll get very frustrated if you're just clicking in the middle of the ceiling thinking you're actually going to select it. It won't ever happen. First thing we want to do is edit the boundary. What does that bring us up? Sketch mode. Now we didn't create a boundary when we did the ceiling. It automatically did it by selecting the walls that bound that ceiling. But just like in any other sketch mode, we can do a lot of different things here. We just have to create a boundary. So the way they're going to ask us to do it is create some reference planes. Click the reference plane button on the work panel shown in figure 9.21. Alright, and we're going to come from the middle of this wall here and drag it on over here. And then we're going to come from the middle of this here and drag it straight down. And that gives us the center of the room, basically. Press escape a couple times or click modify to clear the reference plane command. I'll just click modify. On the draw panel, this is item number 7. Click the boundary line button. You see an expanded list of sketch choices. Boundary line. I want to draw a circle. Draw a circle from that intersection. And I want the radius of that circle to be 4 foot. This is a pretty big opening in this ceiling. On the model panel, pick the finish mode. So now what do I have? I have a big hole in my ceiling. So I'm done, right? No, this is the beginning of creating an actual soffit. Creating a soffit. Soffits are nothing more than walls with the base offset. This makes sense if you think about it. If your floor level moves, you'll certainly want the distance from the finished floor to the bottom of the soffit to remain consistent. This one's going to be easy. Here are the steps. On the Architecture tab, click the Wall button. Type WA. In the Type selector, select Basic Wall Interior 3 1/8 inch partition. So we'll do that. Basic Wall. Interior 3 1/8. There we go. In the Properties dialog box, set the base offset to 14 feet. So what are we doing?
Building a wall 14 feet.
Yeah, we're moving the bottom of the wall, right? So instead of it being at level 1, it's 14 foot above level 1. Item 4, set the top constraint up to level 3. You're now ready to place the soffit. You'll add it to the radial hole in the ceiling. If you had nothing to guide you, you would need to draw the wall physically by using the arc sketch function. In this case, you can simply pick the radial portion of the ceiling opening. With the wall command still running, click the pick line icon on the draw panel. You're going to have to draw this in 2 pieces. It won't do it as one piece. Mouse over the radial, a blue line appears. Make sure it's the inside of the opening. Then press the tab key twice. It's still 2 lines. Trust me. And click. There you go. Let's see if I'm on the wrong side, which I am. Hold on. Let me undo this here for a second. Because I screwed one very important thing up. And I'm gonna zoom in here so you can see. See how my blue alignment is on the inside of the circle?
Yeah.
That's where we want it. So it draws the wall on the inside of the circle. All right. Everybody good with this so far? Great. Item 4, press escape or click modify. Your soffit is complete. Next, you'll add a secondary ceiling to the inside of the soffit. This procedure is carried out exactly as it was when you added a ceiling to the entire room. In the project browser, go to the level 1 ceiling plan and zoom in on the ceiling with the soffit if you aren't already there. On the Architecture tab, click the ceiling button. Select the compound ceiling, wood veneer over metal framing. It's already selected. Click the Edit Type button. Click Duplicate. Okay, and we're going to call this mahogany veneer on metal framing. Because if we're going to go through all this trouble of having a circular hole in our ceiling, it probably shouldn't be the same material, right? So we're going to go into the structures row. We're going to take this material, we're going to change it from cherry. And you're going to go, oh, there is no mahogany. Uh-oh, what do I do? There's a couple things you could do. Literally, you could just put a different wood on there. You could also open an existing library and navigate to the AutoCAD library. You could create a new material. We're not going to do that this evening. That's a little bit more of an advanced topic. We will, towards the end, if we have time, we'll get into those things. But for tonight, what I want you to do, sit in mahogany, type in wood, and pick a wood. I don't care what it is. It can be the door panel, it can be the oak flooring. Just pick a different material.
So, but for the project, we could find some library to pull from them, right?
Yes, there are libraries out there. You could also create a new material by creating an asset, but I don't want to get into creating a new material because we really need to explain every part of the material browser to you in order for you to understand it. Like, I could quickly create mahogany, and that wouldn't help you. It would just make you more confused. But essentially, you could go into an asset, and Autodesk already has all of these assets that are in here. And you could go to wood, and I believe there's a mahogany one in here already. Okay, but an asset is not a material.
Oh.
An asset is properties that you then apply to a material. So we'd have to create a new material. Well, since you asked, let's just kind of do it. Create a new material. I can go into this identity and say I want this to be a mahogany. It would help if I spelled it properly. Mahogany. And I could go and set all this stuff up and say, hey, it's a wood. Comments.
Basically, you're taking an asset and you're profiling it.
No, I'm taking an entire, I'm creating a new material.
And
And I'm going to add the asset to it here in a second.
So the asset is just kind of like a property that you apply to a new material.
Yeah, so I clicked over here, and what you saw is all this image, all this appearance information came up.
Yeah.
This JPEG that is the image came up. So I've essentially created a material now that is mahogany. I've used the assets over here of mahogany. But an asset and a material are not the same thing. Assets are the properties that will infill a material. So I could use this mahogany asset on several different materials. Does that make sense? And if I edit that asset, any material that that asset is applied to will change. Does that make sense? So if I'm creating a new asset, I need to make sure it has a unique name and do some other stuff to it. But basically what it's infilled is all of this appearance information. And I could come in here and change the surface pattern. Let's just do wood 2. So you can see that. Cut pattern, let's just go ahead and make that plywood 1. Okay, so we've created a new material, not in the book, right? All the things I've just taken you through, not in the book. Because mahogany used to be a default material, and they just haven't updated the book, that aspect of the book. But we're here, so it's done. We're going to say that's the material we want. It's here as mahogany. Okay. Okay. And we want this offset to be 14 foot 1 inch. And we want... Okay, so what have we got a warning about?
That what we just built is invisible.
Yeah.
Plan.
We need to adjust our view range, right? And why do we need to adjust our view range? Because the cut plane's at 14.6. So it's cutting at 14.6 and it's looking up. Does that make sense? To level 3.
5 inches.
Where do we need to, we need to move this to like 14 foot. And now does it look something like the book? Yeah.
Yes.
So we had to move that, we had to make that new material because it wasn't in the book. So if you missed any parts of that, go back and look at the video and it will help you walk through that. All right. Now, the book says it's a very good thing. Don't assume it's all the way you want it to. Cut a section through it. And there you go. Not the most stunning soffit. I probably would have built it a little bit different if I was actually designing it, but that's essentially what we're looking for. Here's our irregular ceiling. Here's our soffit walls. Here's our new ceiling. The idea is that there will be something up here that supports all of that eventually. Like stuff doesn't just float. So if you draw stuff and it looks like it just floats, you should address that issue. Alright. And I'm going to delete this section because we're not need it. Okay. And we'll keep moving forward in the book. Adding light fixtures to the ceiling. Adding light fixtures to a Revit architecture model isn't a difficult task, but you must follow a few guidelines to achieve success. Installing lighting. For example, you must work with the ribbon to find a face in which to insert the component. Go to level 1 ceiling plan where you've been adding the wood ceilings. We're already there. On the architecture tab, click the components button. Have we inserted components at all yet? Components are like blocks, so furniture, all sorts of stuff can be a component. So we're going to click there on components. Oh yeah, we used them for footings, it looks like. On the model mode panel, the modify place component load family. We're going to go load family. Then we're going to navigate to lighting architectural internal pendant. Lighting architectural internal. Oh look, there's all sorts of lights. Pendant light hyphen disc. There we go. And what's showing you right now is the actual spread pattern of the light that outputs. Open the file. Alright. You can see that now it's there. And what we want to do is select the fixture, click the move button, type SC for snap center. This doesn't want to snap center for me. So I'm going to place this. I'm going to grab it. I'm going to move it. I'm going to move it from its center. I'm going to type SC and snap it to the center of that. I could have done that with detail lines also, but this works just fine. Item 3, open the section called Section at West Training. Notice the light fixture is, did we not name our section last time? Yeah, I think that section that we created before, we should have named it section at West Training. So let's recreate that section.
Oh, and then label it.
Yeah. And then we're going to name the section, instead of being section 1, we're going to rename that section at West Training. Okay. Now we're good. And what do we see in our section? A nice little pendant fixture in our room. Did we have to model that fixture?
Thank God. It's easy block.
No, we did not, right? So now we're going to work with this fixture here and copy it. So we want this fixture copied 3 foot on that side. And we could either copy it on that side again using the same method, or we could take this and mirror it along that axis. I don't care how you do it. Either way works, right?
Yeah.
Use your modify tools as you see fit. I think the book asks you to actually copy it 3 foot.
Yeah, copy. Oh, bless you.
Okay. Let's make some more fixtures. In the project browser, go to level 1 ceiling plan. I can just close this view out, and it'll take me right back to my original plan. Or I can go to the project browser and go to level 1. Okay. Now we're going to click on these two. There's a number of different ways to do this. So how this is going to do it is tell us to rotate them and click here on copy. Click and go 90 degrees. That's one way to get those done. You could have got them done by offsetting them again. There's a whole host of ways that you could have got them done. I think this whole soffit is kind of hideous. Let's just give you a little view of it. But that's not the point. Oh, I didn't want to go default view. That's not the point of the exercise, right? The point of the exercise is that you start to understand. Hold on. What happened? Why? I guess because I'm in a ceiling plan, it won't let me do a camera. Okay. So, my opinion, that soffit's a little overdone. Alright. If we came down here and we said, hey, give us a shaded view, that's kind of what the shaded view looks like. We said, give us a realistic view. We can see that there's two different woods, right? There's the darker mahogany and the lighter cherry. Seems to be a very busy soffit for a very small room, in my opinion. But it walked you through the steps of how to create multiple ceilings, create soffit walls, add lighting fixtures. We actually walked through a significant amount of ceiling stuff. Really, we walked through all the ceiling stuff that the book is going to talk about in detail. And we may add some ceilings later in the process, but now you should be able to add ceilings, whether they're bounded by rooms or not bounded by rooms. You can go to sketch mode. You can change them almost any way you want. All right, so we're going to start adding detail to the model by adding components, or adding interior design, as the book would like to call it. Adding plumbing fixtures and furniture. To begin, you'll have to knock out the less glamorous but all too important task of adding bathroom fixtures. In the project browser, go to level 1 floor plan, which we're at. Floor plan, not ceiling plan. Zoom in on the lavatory area and turn off the thin line mode as shown in figure 9.35. Right, this is thin lines right here, right? There's a thick line, thin line. I don't know why it wants us to turn it off, to be honest. but I'm going to leave it on for the moment. As you can see, there is a call out of this area. Double click the bubble, open the view called Typical Men's Lavatory. Alright. With the Typical Men's Lavatory view open, you can start adding fixtures. On the Insert tab, click the Load Family button. Alright, so we're going to go to Insert, which we happen to already be at. Load Family. In the Imperial Library or Metric Directory, browse the Plumbing, Architectural Fixtures, Water Closets folder. That was a mouthful, right? So Plumbing, Architectural, Fixtures, Water Closets folder. Select the Toilet Commercial Wall 3D. Right, don't do the 2D one because it literally is just going to show up in plan, and you want these things to show up in your elevations and maybe some renderings. I mean, if you want to render a toilet. And click Open. Okay. And almost nothing happens. You're like, what happened? Go to the Architecture tab and click the Component button. And it's going to default to the last component that you actually loaded. In the type selector, no, it should be the toilet that we just loaded. In the type selector, make sure the 15-inch seat height toilet is selected. Place it along the north wall approximately 6 inches from the west wall. Alright, so we want to come in here and drag that out till it's about 6 inches. And there you go. You have placed a toilet. Aren't you happy? Because you're not designing a military barracks from the 60s, you'll need some stalls. Unfortunately, Revit doesn't provide any stalls out of the box. But this book you bought does. To add toilet stalls to the model, go to the book's website. And we should already have this stuff, right? This is the stuff I asked you to download at the beginning of the class and put somewhere you could actually find. So we're going to go to the Insert tab and click Load Family. And we're going to browse to that location. For me, it's in the Documents section, ADT 201, Chapter 9, Imperial. And I have this stuff. Select the new files and click Open. And this should probably take a minute because it's going to load all these files into our project. Now, as you start to load more families, what happens to the size of your project file? It gets larger. Now, this is why we don't just open Revit up with every family it ever had loaded into it. We'd never be able to work on the projects. It's gonna make me do them one by one. Shouldn't. No, it did it. Yes. Upgrade, upgrade, upgrade. Okay. And you'll see that now when I click here on properties, I got a whole bunch of other stuff. Toilet stall accessible, toilet stall braced, different sizes, 15-inch seat, 19-inch seat. I have a lot of stuff in here that I didn't have in there before. Select a toilet stall accessible front 3D 60 by 60. Pick the corner of the bathroom as shown in figure 9.37. There we go. There's our stall. The next step is to copy the toilet and add another stall. It'd be nice if the family just fit, but it just isn't a perfect world. Copy the toilet to the right, 6 foot 2.5 inches. So we're going to click on this toilet. We're going to copy it. It doesn't really matter where we copy it as long as we copy 6 feet 2.5 inches. We have another toilet. On the Architecture tab, click the Place a Component button. And what we want to work with this time is select the toilet stall brand 3D 59 by 60 clear. Click the Edit Type. Click Duplicate. Name this 54 by 60. Because obviously 59 is too big, right? And we want to set the width. Instead of 4 foot 11, we want to set that to 4 foot 6 inches. We'll hit OK, and then we can place that stall. Now, is this the best way to do this? It depends on what you're working with. Obviously, this puts something in the wall. It doesn't really need to be in the wall. There are different manufacturers of toilet stalls. So I'm going to deviate a little bit from the book right now. And I'm going to go over here to Insert. And you're going to see this Autodesk Seek thing over here. Now, toilet stall partitions are manufactured items. I.e., there's companies that make this stuff. Bobrick is a major manufacturer. So I'm going to do a search for Bobrick in that Autodesk Seek. It's going to bring up a website that has a whole bunch of families. Hopefully. No products were found. Okay, well, let's put in toilet partitions. Now, this website, BIM Objects, is relatively new. It used to be ran by Autodesk, but now Autodesk has outsourced this service to this new company, BIM Objects. But you can see that there's a bunch of toilet partitions already made. Bradley has toilet partitions. You would probably pick the manufacturer that you are actually working with. And then their family would work a little bit differently than the components that we're inserting. Does that make sense? We're not going to do that so we don't deviate too far from the book. But I want you to know that Autodesk Seek is here. So if you're looking for a specific door, specific window, specific piece of furniture, for example, if I type in Herman Miller. Here's Herman Miller furniture that I can download. I don't have to go model that chair. That's what it looks like. It's not the only place that you can get BIM objects. Obviously, Herman Miller has a whole part of its website that you can go get Revit objects. But it's a very quick way to find information. If we just typed in here chair. Well, evidently it defaulted to kitchen. Armchairs and sofas. You can see that there are literally dozens of brands should you be modeling this stuff as an architect? No. Not unless you're making a custom piece of furniture. If you're getting a piece of furniture or a fixture that is manufactured by product, the first place to start is with that manufacturer. If they don't have a BIM object, a Revit object that you can insert, component, then maybe you model it, but use your time wisely. And if you're going to specify it, ask the manufacturer, hey, do you have Revit objects? 10 years ago, really difficult. There weren't a lot of manufacturers that invested the time into doing this. Nowadays, it's in there. Everything from furniture and fixtures, so let's just type in Trane. And this is not like a, I don't like their, let's type in HVAC. Alright. Like you can get air conditioners already modeled. You can get ductwork already put together and modeled. So there's really no reason for you to guess about a lot of this stuff. And just to prove my point here, Trane is a HVAC manufacturer, right? They make air conditioners, things of that nature. You can contact your local Trane representative and get the actual Revit files for the size of their equipment. So it's no longer just this rectangle that says air conditioner on it. It's the actual equipment that shows you the size. And typically, if these are well done models, they'll show you the clearances that are required, all sorts of other information. So this is really where BIM starts to get useful, is you're putting in stuff at the real size, with real properties, with real information. It can then later be accessed. All right, so apologize for that deviation. So this is just bad, right? Like, I would not want you to actually ever model something this way. Because it's wrong, right? We have a model of a partition inside a wall. But that's what the book asks us to do, so that's what we're going to do for this particular let's see, we're back to the book. With the toilets and stalls in place, you need to add grab bar to the accessible stall. Again, Revit doesn't provide this content. You'll need to either make this component yourself. This is covered in the bonus chapter 2, Creating Families, or use one of them from the book that you downloaded with the bathroom stall. To add a grab bar, follow these steps. Zoom into the accessible stall as shown in figure 9.39. Click on Place a Component. Navigate to grab bar. It should be in here now. Grab bar, 4 foot length. Okay. Place the grab bar along the wall. See figure 3.9. As we go to place it, it's going to look like it's going to be in this wall, but really it won't be. It will place it at the face of the wall. And then we can click on this and we can modify it and say, hey, that really should be exactly 6 inches on the wall. Now, this totally doesn't meet code. I don't want you to confuse what the book's asking you to do with it actually being legitimate and meeting code. So when you're in an architecture office, you'll have to have that code book and that ANSI book open and make sure that you're designing it to where it meets code. All that this book is doing is showing you how you would insert a grab bar as a component. Because you're in the men's room, you'll need to add some urinals. You can fit 2 before you start getting too close to the sink area. And the guy standing next to you. On the Insert tab, click the Load Family button. Browse the plumbing fixtures, architectural urinals. Urinal 3D. Actually, we're not going to do it that way. I'm going to show you how to load a real urinal from Autodesk Seek or BIM objects, because that's what I encourage you to do. If you're using a Kohler urinal, then download the right urinal so you have the right information. Let's hit cancel here. Let's go here and type in urinal. It will search. Take us to bimobject.com. And you can all sorts of different urinals. You can pick the one that let's do this one. That looks like an expensive urinal. Click on this download. We don't want a 3D Max file. We don't want an AutoCAD file. We want the Revit file. Download. And what's it going to say? You don't have an account. So I happen to have a Google account and an Autodesk account or a LinkedIn account. Let's pick one of them. I'll pick my Google account. Whatever, allow. You probably all have Google accounts as well. It's an easy thing to do. Yes, yes, yes. My occupation. I think I'm an architect sometimes. What BIM and CAD systems do you use? Huh, Revit. That's all I'm going to tell them I use. I agree. Register. How did you hear? Other, I guess. So you're going to have to register for the account, but it's a small price to pay to actually get what you need. So once you've done that, we'll go back to download. We'll download the Revit model. You want to open or save? I'm going to save it, and I'm going to save it as... Put it somewhere where you know you can find it. I'm going to put it in Chapter 9. After I've saved it, I'm going to open it. And the reason I'm going to open it is just to show you how to do it this way. Sure, it needs to be upgraded. Okay, this file I have open right now is the family. That's a nice looking urinal, right? Alright. And you can see here it's asking for a couple plumbing connections, like water in, sanitary out. I'm going to click this button right here, load into project. And it's going to load it into my open project. It's just like I had loaded it from the file, but now I have it loaded into the project. And you can see that this urinal is an element that hosts to a wall. So it's not going to let me place it out here. It's kind of like a door, right? The doors. It will let me place it to a reference point. It will let me host it to a wall. So instead of using their urinal, we're going to place their urinal right here, which is a horrible design. Oh!
That'd be weird.
This bathroom is like the most awkward bathroom you've ever seen, right? Don't pay attention to that. So they have a oh, that's horrible.
That's a men's bathroom.
And they want us to copy another one.
It's just a happy,
And yeah, everybody's really close and happy. It's horrible.
it's camaraderie.
Because now we're going to put a counter over here with sinks in it.
Oh God.
So obviously there's too much stuff in here, and the layout makes zero sense. But that's not what's important about this chapter. What's important about this chapter is you start to learn how to place these elements. Would we agree? Okay. All right, so let's tackle one more thing before we call it an evening. We're going to put in the sinks. On the architecture excuse me. On the architecture tab, click the Place a Component button if it isn't still running. In the type selector, find the double sink rounded 24-inch deep. All right, architecture tab, component. Double sink, 24-inch depth. All right, and if we hit spacebar, it will move this component around, right? Okay, so does it fit? No, it doesn't. It's in the middle of the door swing. If your door is 12 inches to the left, then you have a problem, don't you? Luckily, you're using an application that allows you to stretch components dynamically. Select the sink, click the leftmost stretch grip, and slide it to be flush with the door opening. Alright. This also violates code. And the reason it violates code is this would have to be an accessible door, and you'd have to have actually 12 inches clear on the push side of that door. So there really couldn't be anything within 12 inches of that door on this side. So what have we learned about the book and laying out restrooms?
Not for code.
Absolutely do not follow these as a guideline for how restrooms should be laid out. The only thing that the book has showed us is how to insert components, how to insert, we did a little bit of a tangent there, and we went out and we found a component that wasn't in the book. It wasn't a default, it was an actual manufacturer. That would be this Kohler urinal. And it also showed us how to stretch a dynamic component. But the layout of this bathroom is just wrong in all sorts of different ways. But to show you everything that we've done up to this point, we'll do a camera. And you can start to see that this bathroom is coming together. Now, obviously, we've already talked about how the design is bad. It leaves some things to be desired, but we've added a lot of information into the model very quickly, right? So we can look in a 3D view and go, hey, yeah, this is probably a problem here, and that's probably a problem there. There's not a lot of privacy there. Maybe I don't want a urinal there. That's the advantage of starting to model this stuff in 3D. All right. So we're going to call it a night there.